Welcome to Module 3, Lesson 10. So, going to be teaching another property here. And this is called the distributive property. Now, it will be very similar to something that we've kind of touched based earlier on, but we're going to go into really good depth here to kind of make some more understanding about it. So, today we are going to figure out if I can use the distributive property as a strategy to multiply and divide. So, distributive property. This is basically saying, it's kind of like the cutaway method. Remember how we would have a picture here. And let's say I had 6 groups of 3. So 1, 2, 3, 1, 2, 3. So that's 4 groups, 5 groups, and then 6 groups. Just double checking, 1, 2, 3, 4, 5, 6. So basically, remember when we would do this. We cut it right here, see that this is 5 times 3, down here is 1 times 3, and then you can glue them back together to find your total answer. This would be 15, this would be 3, together would be 18, so 6 times 3 is 18. Once again, going through that kind of quick because we've mentioned before, giving a quick reminder, this is kind of what we're talking about. Now this is the distributive property. We're now going to be using this on a grander scale, and I'm going to show you how we can do it in division, because it can be used in division for this one. So, and this is where it kind of gets a little weird. This is the part that it works. I'm not a huge fan of doing it this way, but technically you can do this. So let me show you what I mean. So let's say we had 7 times, let's say 6. 7 times 6. I'm going to draw this out. That we have 7 groups, so 1, 2, 3, 4, 5, 6, 7, and that there's 6 in each group. So 1, 2, 3, 4, 5, 6. And you repeat this all the way across. Hopefully this is looking familiar because we've done this plenty of times before. And I want to make sure we remember what an array looks like. So far we haven't done anything different. Now, in the past, we would split up the groups. We would cut it like right here and say that's 5 groups of 6 plus 2 groups of 6. So it would be 5 times 6 plus 2 times 6, and you do it that way. Now, this is the reason why I'm not a huge fan of this, but because of the commutative property, it works. I just want to be very careful how I teach this because I don't want to make a misconception. Because we understand that you can't change how many are in each group, correct? You can't do that. If this is 7 times 3, you can't change the 6. You can break up the groups, and you can't break up how many are in each group because that gets weird. But, technically remember, if I turn this sideways, this now becomes 6 groups of 7. So just kind of keep that in mind as we work on this, because that right there is kind of the defining point that allows this to happen. But yeah, anyways, just kind of keep that in mind as we go forward with this. Because normally, once again, I said I'd split that 7 because I said you can't break up the 6. But it technically can, but it's because of the commutative property. Because remember, if I turn it sideways, the 7 and the 6 swap, right? So I can technically cut it this way. And now I can say that there are 7 groups of 5, which is over here. So there's 1, 2, 3, 4, 5, 6, 7 with 1, 2, 3, 4, 5 in each group. Plus, how many groups are here? 1, 2, 3, 4, 5, 6, 7 times, and how many are in each group? 1. So this is something you are allowed to do. I'm not a huge fan of it because it usually gives the perception that you can break up how many are in each group, which isn't true entirely because commutative property. If you look at it sideways, it literally shows you that you're just breaking up the groups in a different way, the commutative way. So this is a manner that works. So you can just go ahead, go down the way and solve this. This would become, just can count by 5 7 times, 5, 10, 15, 20, 25, 30, 35, plus 7, which equals 40, 42, which is what that would be. And you can double check, you can count and pause, but that is what it would be. You can do this. I'm not a huge fan of doing this way because it kind of, at least to me, it gives the illusion that you can change how many are in each group. It's not entirely true. The reason why this works is commutative property. You turn it sideways, you're technically breaking up how many groups there are. But at the same time, the biggest thing is that this 5 and the 1, when you put it back together, still equals 6. That is the main reason why this works. That's why if we were to split the 7 into 5, the 5 and the 2 will add back up to be 7. This is a fancy thing in math called, like when you're breaking up the puzzle and putting the puzzle back together. If you have 10 puzzle pieces and you move 3 over here and move 7 over here, when you put them back together, there's still 10 pieces. If I put 7 over here and 3 over here, and then only brought 4 back over here and then 3 here, it equals 7 now. You're missing 3 pieces. The only reason why this works is because you're still using all the pieces. Please keep that in mind. You're still using all the pieces. Now, I'm not going to focus too much on the multiplication one because the multiplication one I feel is still relatively straightforward, especially since we've talked about it before. The one that I really want to focus on right now is the division one, because the division one can be a little tricky here. Now, let me show you what I mean by that. Let's say I'm going to use a problem from the problem set just to make sure that things kind of work the best. Let's say I had a problem that said 56 divided by 8. And, well, I don't know what that is. I'm not sure what that means. I don't know my division very well, which is something that you guys might be thinking. That's okay. Just like with the multiplication, saying, oh, I can't multiply with those big numbers, break it apart, solve separate, glue back together. You can do the same thing with division. Now, I will say this. I'm not drawing 56 circles right now. Because technically what you can do, you could draw 8 baskets and then count up to 56 going that way. Which you can do, and if you need to do that, that's fine. But I want to practice this strategy. Going up the same thing, this 8, you can't change that 8. You can't. Because that's how many, it's either how many groups you have or how many are in each group. If I split that up, things get weird. But in division, you can split up your total. You can split up how many are in each group. It's kind of basically saying, I'm now making 2 separate totals, and I'm going to put those totals back together. Let me show you what I mean. So, over here, let's say I have 40 divided by 8. Now, this is the part that gets a little bit weird. I know the divided by 8 part can't change. So I'm going to say divided by 8. Now, that being said, this is 40. 40 and what make 56? And you can do your math. You can do 56 minus 40, and you can find that the answer is 16. 16. And then you can solve this separately. 40 divided by 8, a little bit more manageable. You can double check my math on this, but that equals 5. And then 16 divided by 8 is 2. So the answer is 7. And you can double check that, because if you were to skip count by 8 7 times, you would find 56. And you can double check me on that. But I want to be kind of specific here, because on this problem set, it will give you one of these numbers at the bottom, and for that time being, you'll be able to like, okay, it's that number plus something equals this number. So 14 plus 16 is 56, or sorry, 40 plus 16 is 56, so on and so forth. I want to give you another example though. I'm going to use this actually the same thing. I'm going to keep the divided by 8 part because that will be the same. And we're going to keep the 56. Now, this is the most important part of the distributive property in division. 8 has to go into it. You can't just choose a random number between 1 and 56. You can't. Well, let's do an example there. Let's do 1. Let's choose 1. 1 divided by 8. So 1 and what equals 56? 55. Technically, I wrote this out accordingly, but there's a problem. There's a big problem here. Look at this. 1 divided by 8. Can I divide 1 into 8 groups? No, I cannot do that evenly. Can I do 55 divided by 8? No, you can't. So, what you need to do is that you need to ensure that whatever number you choose is divisible by 8. So, 1 through 7 we know won't work because it's less than 8. But technically, Could I use 8 there? Yeah, I technically can use 8 there, because 8 goes into 8. But going on that, then that's going to change this answer here, or this number here. So 8 plus what equals 56? So in order to find that, I can just go 56 minus 8, do my borrowing strategy. That becomes 8, and that becomes 48. And you can do your math. You can figure it out. Does 8 go into 8? Yes, that one works. Does 8 go into 48? Do your math on that. You find out, yes, that one works. Which means now you can solve the problem. Because I will say this, I'm giving you a heads up right now, I will see quite often, I'll see some scholars do this. We're like, well, I like the number 30, which means that over here is 26. And then they'll sit here and they'll kind of stew on it for a while. And they're like, well, but I can't find out how 8 goes into 30. And I'll come around and be like, well, does 8 go into 30? They're like, well, I don't think it does. And they'll count and go 8, 16, 24, 32. Okay, so I went over 30, so it doesn't work. But I can't find out how it works. Well, I asked them, well, right there, you just told me, does 8 go into 30? And the answer is no, which means you cannot use that number. But we just found one. We found 32. So you could use 32. So just keep that in mind. You need to make sure that whatever you're splitting it into, it needs to be divisible by that number. So 8 could work, 16 could work, 24 could work, 32 can work, 40 can work, 48 can work, so on and so forth. Now, I do understand why they did 40 here, because 40 is a nice round number. You will probably be able to find that number a little quicker than finding 32 divided by 8. And well over here, and then we'll leave that 16. So just kind of keep that in mind. When you are doing this, you must find a number that is divisible by this. So I'll give you guys one more quick example here, and then we shall move on, or we'll kind of wrap up. So let's say I had 64 divided by 8. So a little bit bigger. It's a little bit different than the last problem, but it's still in 8s. I'm kind of going back and forth if I want to use 8 still again here. You know what? Let's change it. I'm going to say 49 divided by 7. So right there, we already know what the last half of each one of these problems is going to be. It's going to be something divided by 7. Now, remember, whatever number I put into these two spots, when I add them together, they must equal 49. And that both of them must be divisible by 7. So, can I put 1 here? No. Typically, find one and you will find the other one. Just kind of keep that in mind. Don't find them both and then determine if 7 goes into them. Find one. If 1 does go into 7, then you can move on. So does 1 work? No. 2? No. 3, 4, 5, 6, 7. 7 does work. It does. But I'm going to push you a little bit more, see what happens. And you can maybe find 14. So if you found out 14 goes right here and you decide to go with 14, you now need to determine 14 and what equals 49. Just do a quick math there. 49 divided by 4, or sorry, minus 14 becomes 35. And now do your division. 14 divided by 7 equals 2, or what times 7 equals 14, which would still be 2. 35 divided by 5, or what times 7 equals 35. You can check all my math on this. Well, that would equal 5. So 2 plus 5 equals 7, which means 49 divided by 7 is 7. So just kind of keep this in mind. Keep this strategy flowing through your head. I will promise you, at first, this is one of those things that you're like, what? That's going to happen a lot this year. You probably have already done it quite a bit. But keep that in mind. Distributive property is, as long as you're keeping all the pieces of puzzles together, and when you put it back together, it's still the same amount of puzzle pieces, you're good. Once again, using that 10 pieces, we talk about pieces we're missing, but imagine that I did this. I had 10 puzzle pieces. I put 5 over here, 5 over there, and then when I brought them back together, I had 13 pieces. Where did the other 3 come from? So make sure, same thing, make sure you don't leave things out, but make sure you don't add things back into it. So those are kind of the 2 big rules with the distributive property. Don't forget to use all your pieces, but also don't make more pieces, if that makes sense. So hopefully Hopefully this was helpful. Hope you guys learned something from this. And I hope you guys have a great day.